History of Swift. Swift is a modern programming language introduced by Apple in 2014. It was designed to be a safe, fast, and expressive language, aiming to be a better alternative for Objective-C for writing software for iOS and macOS. Swift was developed by Apple as a proprietary language initially, with its first introduction at Apple's Worldwide Developers Conference, WWDC, in 2014. It combined features from C and Objective-C without the constraints of C compatibility. Swift was made to be more resilient to erroneous code, safe, to support playgrounds for easier learning, and it incorporated modern concepts such as closures, generics, and type inference. Its syntax was more concise and expressive. In 2015, the Swift language was open-sourced and has since been available on Linux, as well as Apple's platforms. Swift versus Objective-C. Swift and Objective-C are both programming languages used for developing iOS and macOS applications. Swift is a modern language introduced by Apple in 2014, offering simplicity, safety, and improved performance. Objective-C, on the other hand, is a more mature language based on C and has been used by Apple since the 1980s. Let's compare the two with a simple class definition example. In this example, we define a vehicle class with a property current speed and methods description and make noise. In Swift, the syntax is concise. Type inference reduces the need to explicitly state types, and string interpolation simplifies string formatting. Objective-C requires more verbose syntax, explicit typing, and lacks modern features like string interpolation. Swift's modern features make the language more approachable and easier to maintain, while Objective-C's direct ties to C allows for greater compatibility with C and existing C libraries. Although Objective-C is still in use, Swift is becoming the language of choice for new iOS and macOS development. Installation and setup of the development environment. The primary development environment for Swift is Xcode, an integrated development environment, IDE, which includes a code editor, debugger, and many other tools. To set up Swift's development environment, you need to install Xcode from the Mac App Store. Once installed, you can create a new project, select a template, and start writing Swift code. Xcode also contains an interface builder for designing your app's UI and can simulate different iOS devices. It's important to keep Xcode updated for the latest Swift features and iOS support. For Windows or Linux, alternative solutions involve using a virtual machine or a cloud service that provides a Mac infrastructure. Swift Playgrounds. Swift Playgrounds is an interactive environment that allows you to write Swift code and see the results immediately without needing to create a full app. It's great for learning Swift syntax and experimenting with code. In the provided code snippet, we declare a variable greeting with the value hello playground. The var keyword is used for variables whose values may change. We then use the print function to output the value of greeting to the console. When this code is run in a Swift playground, you'll immediately see hello playground printed out. Basic syntax. In Swift, you can declare variables using var and constants using let. Variables can have their values changed after being set, while constants cannot. The code defines a variable, myVariable, and initializes it with the integer value 42. It also defines a constant, myConstant, with the integer value 100. MyVariable can later be altered, but attempting to change myConstant will result in a compilation error. Variables and constants. In Swift, variables are used to store information that may change during the execution of a program, while constants are used to store information that remains the same throughout a program's execution. The keyword var is used to declare a variable, which in this case is myVariable, initialized with the value 10. This value can be changed later in the program. The keyword let declares a constant, which here is myConstant, with the value 42. This value cannot be altered once it has been set. Data types. Swift is a type-safe language, meaning it helps you to be clear about the types of values your code can work with. If part of your code requires a string, you can't pass it an int by mistake. Swift provides a variety of data types for different purposes, including string, int, double, bool, and more. In the code example, greeting is a variable of type string, initialized with the value hello world. The variable age is of type int, a whole number, initialized with the value 29. The price variable is of type double, which can hold both whole numbers and fractional numbers, with a value of 19.99. Lastly, isVisible is a Boolean variable of type bool, initialized to true, which can either be true or false. Console output. In Swift, printing to the console is a fundamental way to output information. This is commonly used for debugging or giving the user feedback. The primary function to achieve console output is print. The print function outputs the specified string to the console. When the above code is executed, it displays hello world in the console. The print function can handle various data types and can interpolate variables and constants in strings to combine static text with dynamic values. Comparison operators. Comparison operators in Swift are used to compare values for equality, inequality, and other relational conditions. These operators include equals, e equals, a equals, and d equals. They are fundamental in control flow as they typically direct the flow of execution by evaluating conditions in if statements, loops, and other control structures. The provided code demonstrates various comparison operators in Swift. Variables first score and second score are being compared using different operators. The equals operator checks if both scores are equal and stores the Boolean result in isEqual. The equals operator confirms if the scores are not the same, and isNotEqual captures this result. Is greater than reflects whether the first score is larger using, while is less than indicates if it is smaller using then. Operator checks for the first score being greater than or equal to the second score and stores the result in is greater than or equal. Lastly, is less than or equal is set to true if first score is less than or equal to second score using the equals operator. Logical operators. Logical operators in Swift are used to modify or combine the Boolean logic values true and false. These operators include logical not, logical and logical or. They are typically used within conditional statements to determine the flow of execution based on multiple conditions. The code snippet shows how to use logical operators. The statement allow entry uses the logical not operator to negate the Boolean value of allow entry. This means that if allow entry is false, allow entry is true, and the message access denied is printed. The logical and operator, an, combines has invitation and knows the secret handshake. Both must be true for the statement to execute, printing the welcome message. The logical or operator means that if either has invitation or knows the secret handshake is true, the lounge area message will be printed. If, else statements. In Swift, if, and else statements are used for executing code based on whether certain conditions are true. The if statement checks a condition, and if it is true, the code inside the if block executes. An else if can be used to check additional conditions if the if condition is false. Lastly, an else can be used to execute code if all the previous conditions are false. In the provided code snippet, a variable score is set to 85. The if statement checks if score is greater than or equal to 90. If it were true, it would print excellent. Since the score is 85, the if condition evaluates to false, and it then checks the else if condition. This condition asks if the score is greater than or equal to 75, which is true for 85. Therefore, great gets printed. If both conditions were false, the else block would execute, printing OK. Switch statements. A switch statement in Swift provides an alternative to the if statement for responding to multiple potential states of a single value. With switch, you define a value to consider and write several possible cases to match against that value. Each case can lead to a different branch of code being executed. In the code, some value is evaluated in a switch statement. There are cases for the values 1, 2, and 3, printing 1, 2, and 3, respectively. If some value is none of these, the default case prints something else. Since some value is 3, 3 will be printed. Note that unlike some languages, Swift switch cases don't fall through to subsequent cases by default, hence no need for break statement in each case. Ternary conditional operator. The ternary conditional operator is a concise way to evaluate one of two expressions based on a condition. It's written with the syntax condition not, true expression, false expression. If condition is true, true expression is evaluated and its result is returned. Otherwise, false expression is evaluated and its result is returned. In the code snippet, the condition marks equal 50 is being evaluated. Since marks is 75, which is greater than 50, the ternary conditional operator evaluates the true expression, which is pass. If marks were less than 50, it would evaluate the false expression, which is fail. Thus, the variable result will contain the string pass. For-in loops. In Swift, for-in loops are a convenient way to iterate over a sequence, such as arrays, ranges, or strings. This type of loop executes a set of statements for each item in the sequence. The code defines a for-in loop that iterates over a range from 1 to 5. For each number in the range, the loop prints a string interpolating the current number. The index variable is automatically created within the loop scope and holds the current value during each iteration. While loops. While loops in Swift execute a block of code as long as a certain condition is true. It's a fundamental control flow tool used to repeat a task multiple times without having to write the code for that task repeatedly. In the provided code, we have a variable sum initialized to 0. The while loop begins by checking if sum is less than 100. If the condition is true, the loop's body executes and adds 10 to sum. After the body executes, the condition is checked again. This loop will repeat until sum is no longer less than 100. In this example, the loop will terminate when sum reaches 100 after 10 iterations. Repeat while loops. In Swift, a repeat while loop is a variation of the while loop, which always executes the statement block at least once before checking the condition at the end of the loop. This is useful when the loop must be executed at least one time, regardless of the condition being true or false when first evaluated. In this code snippet, we initialize a variable count with a value of 10. We then enter a repeat while loop where we print the countdown message with the current value of count. After printing, we decrement count by 1. At the end of the repeat block, we check if count is still greater than 0. If it is, the loop executes the block again. This continues until count becomes 0, and the condition count 0 evaluates to false, at which point the loop terminates. The difference from a regular while loop is that the print statement will be executed at least once, even if the initial value of count was 0 or less. Control transfer statements, continue, break. The continue statement tells the loop to stop what it's doing and start at the beginning of the next iteration. It's used to skip the current loop iteration and continue with the next one. The loop iterates over the numbers 1 through 5. When it encounters the number 3, the continue statement causes the loop to skip the rest of the current iteration. Therefore, it doesn't print the number 3, but it continues with 4 and 5. Guard statement. The guard statement is used to transfer program control out of a scope if certain conditions aren't met. It is similar to an if statement, but it provides an early exit and requires an else clause, ensuring that the scope is exited if the conditions are not satisfied. This makes code easier to read and helps in avoiding nested if statements. In the code snippet, the guard statement checks if the dictionary person contains a value for the key name. If it doesn't, the function exits by executing the return statement within the else clause. If name does exist, it is unwrapped and assigned to the constant name, and hello name is printed. The guard statement ensures that name is available for the entire scope of the function, avoiding nested optionals. Defining functions. In Swift, functions are self-contained chunks of code that perform a specific task. You give a function a name that identifies what it does, and this name is used to call the function to perform its task when needed. This defines a function named greet that takes a single string argument named person. The function returns a string. When the function is called, it interpolates the person argument into a greeting message and returns that message. The string syntax indicates that the function returns a string value. Function parameters and return types. In Swift, functions can accept inputs known as parameters, and they can also return a value. Parameters are specified within the parentheses following the function name, and a return type is indicated after the arrow bash. In the given function greet, the parameter is person of type string, which means it expects a string input when the function is called. The return type string, specified after the arrow, indicates that the function will return a string value. The function concatenates the input person within a greeting message and returns it. External and internal parameter names. In Swift, functions can have both internal and external parameter names. The internal name is used within the function's body, while the external name is used when calling the function. This helps make function calls more expressive and similar to natural language. The function greet takes two parameters, external name and internal name. When calling the function, we use person and day as the external names for clarity in the context of the call. Inside the function, external name is used as the person's name and internal name as the day. The function returns a greeting string. The call to the function uses person and day, followed by the actual arguments Anna and Tuesday, respectively. Default parameter values. In Swift, functions can have default parameter values. When a default value is specified for a parameter, it's not required to pass a value for that parameter when calling the function. If no argument is provided, the parameter uses the default value. In the provided code, the function greet has two parameters, person and greeting. The greeting parameter is given a default value of hello. The function is first called with only the person argument, so it uses the default value for greeting. In the second call, both person and greeting are provided, so the function uses the provided value for greeting. This showcases how default parameter values can provide flexibility in function calls. Variadic parameters. In Swift, variadic parameters allow you to pass a variable number of arguments into a function. These arguments are of the same type, and within the function, they become available as an array of that type. A function may have at most one variadic parameter, and it is typically placed last in the parameter list to accommodate the variable number of inputs. In the code, the function sum of numbers is defined with one variadic parameter, numbers, that accepts 0 or more int values. Inside the function, numbers is treated as an array of ints. The reduce function is used to sum up all the elements in the numbers array, starting with an initial sum of 0. Finally, when sum of numbers is called with a list of integers, it returns the sum of those numbers. In-out parameters. In Swift, functions are typically used to perform some operation and return a result. Sometimes, however, you might want to modify the values of the arguments passed to the function. In-out parameters allow you to pass a variable to a function and have the function modify the variable in place. To mark a parameter as in-out, you use the in-out keyword before the parameter's type. It's important to note that in-out parameters cannot have default values, and variadic parameters cannot be marked as in-out. When passing a value to an in-out parameter, you must prefix the argument with an ampersand and to indicate that it can be modified by the function. In the code provided, the function swap2ints takes two in-out parameters, a and b, both of type int. Within the function, the values of a and b are swapped. To invoke this function, two integer variables, myFirstInt and mySecondInt, are defined with the values 3 and 107, respectively. When calling swap2ints, the ampersand an is used to indicate that the function is allowed to modify the variables. After the function is called, myFirstInt holds the value that was originally in mySecondInt, and mySecondInt holds the value that was originally in myFirstInt. The variables are modified directly, and the changes persist after the function call completes. Functions as first-class types. In Swift, functions are considered first-class types, which means they can be used in the same ways as other types. They can be assigned to variables, passed as arguments to other functions, and returned from functions. Here, add and subtract are simple functions that take two int parameters and return an int. The function print result of operation accepts three parameters. The first is a function type that takes two ints and returns an int, and the other two are int values. It then calls the passed function with a and b as arguments and prints the result. We then call print result of operation with both the add and subtract functions, showing their use as first-class types. Nested functions. Nested functions are functions defined inside other functions. They can organize code that's logically connected and keep it hidden from the outside world. A nested function is only visible to and can only be used by the enclosing function. In the example, outer function defines a local variable value initialized to 10. Inside it, inner function is defined and increments value by 5. When outer function is called, it subsequently calls inner function, which modifies value. Finally, outer function returns the updated value of 15, demonstrating how the nested inner function can interact with the local variables of the outer function. The inner function cannot be called from outside outer function, illustrating the scope rules in Swift for nested functions. Closures. Closures are self-contained blocks of functionality that can be passed around and used in your code. Closures can capture and store references to any constants and variables from the context in which they are defined. Swift handles all memory management involved with capturing for you. Closures take on three forms: global functions, nested functions, and closure expressions. In this code, sorted by is a method that sorts an array of values based on the closure provided. The closure is a block of code that takes two string values and returns a boolean indicating whether the first value should come before the second in the sorted array. The yay operator in the closure defines a descending sort order. The reversed names variable receives the sorted array. Trailing closures. In Swift, if the last parameter to a function is a closure, you can use a trailing closure instead. This syntax is useful when the closure expression is too long or complex to fit on a single line. Trailing closures are written after the function calls parentheses, even though they are still an argument to the function. In the provided code snippet, the fetchData function accepts a closure as its parameter. The function is then called with a trailing closure syntax. Instead of passing the closure inside the parentheses, it is written after closing the parentheses of the function call. The print statement, data fetched successfully, will be executed once the fetchData function calls the closure after fetching data.